Alright, express the vector r theta. Express the vector, I'm sorry, in r theta notation. That is, we want magnitude and direction. So we have the vector 12 centimeters in the x direction, negative 16 centimeters in the y direction. So we need to be able to get that into r theta notation. So this is xy notation. And the answer is 20 centimeters, 307 degrees. I would like you to see if you can come up with that answer. I'm going to do a problem like this in more detail. You should be able to convert this into r theta notation, 20 centimeters, 307 degrees. Now, what we're going to do most of the time when we add vectors is we're going to add them by components. And just to give you a conceptual picture of what's going on, if we want a plus b, then we can think of it as taking the x component of a, adding it to the x component of b, taking the y component of a and adding it to the y component of b, then resolving those x and y components into r theta notation. So here I'm printing out what I just said, and I'll let you pause this so you can jot this down if you wish to. I'm going to do an example here. Okay, you fly east in an airplane for 100 kilometers. You then turn left 60 degrees and fly 200 kilometers. How far from the starting point are you? So you may remember we found how far east and we found how far north. So now you can use those two pieces of information to find out how far you are. So that would be the diagonal from the start to the end. How far are you from the starting point? And I will let you pause and figure that out and then come back and check your answer. The answer is 260 kilometers. So we had 200 kilometers east, and we had, I want to say, 170 kilometers north. And so you're resolving 200, 170. I'm sorry, you're converting that into r theta notation. And now to find the angle, it's the same thing. Now we want the angle that the vector makes from the start to the end. And I'll let you work on that. Pause the video, come back. It turns out it's 139 degrees. And in what direction from the starting point are you? That's not right. I believe it's 49 degrees. I'm sorry, I put the circle in the wrong place. Okay, I apologize for that. I fixed the slide. So let's look at this again. Now we're looking for what direction from the starting point you are. So I want you to imagine we've got a vector from the start dot to the end dot, and what we're looking for is the angle that makes with the positive x direction. So I'm going to move a calculator in here, and when I tell you that you want to be in degrees, if you have a graphing calculator, that means you want to go to mode and you want to make sure the angle is set on degrees and not radians. And to find the angle, we want the inverse tangent you should make sure you can get these numbers that I'm getting here. And I want the y component, which is, the y component was our 170. So I'm going to divide 170 by my x component, which is 100 plus 100, so 200. And we get 40.36. If you use the unrounded value, which is, let's see if I can duplicate that. The unrounded value is 173. Then you get 40.86. And when I wrote this problem, I actually used the unrounded value. So sometimes we get some slight discrepancies, which usually will come out in the wash if you just don't do your rounding till the end. So the correct answer here is 41 degrees. Okay, and I would like to go through with you, this is the last thing we'll do, this practice problem for adding vectors, and you should pause the video as needed and do this right along with me. Don't just watch me do this. You need to do just what I'm doing. So here's the problem. We have a vector. I can't believe I did that. I'm sorry. We have a vector A, 20 meters at 40 degrees, and we have a vector B, 30 meters at 100 degrees. We want to find the vector sum, A plus B. Now, vector A in x and y components is 15.32 meters, comma, 12.86 meters. So just this little line right here, to do that, I had to find the components of A. So let me remind you how that goes. Let's see. Okay, so the x component is 20 meters times the cosine of 40. Let's try that. 20 times cosine 40. $15.32 meters. And then to get the y component, we have 20 times the sine of 40. 12. Uh-oh. I don't know what I did. Oh, I did 2. Okay. So 20 times the sine of 40, you get 12.86. Well, I rounded. You can do the same thing with B. B is 30 meters, 100 degrees, so you would just do these same things, only you would replace the 20 and the 40 with the values for B, 30 and 100. So if you do all that, you get 15.32 meters, 12.86 meters, that ordered pair for A. You get negative 5.21 meters, comma, 29.54 meters for B. Then the next step is you add the components. So if you add 15.32 meters plus negative 5.21 meters, you will get 10.11 meters. That is your x component of the vector sum. Then you add 12.86 meters, 29.54 meters, you get 42.40 meters. That is your y component of the vector sum. So here's your x, here's your y, and I always make a sketch when I get to this stage. So you want to sketch in the x and y components and the coordinate system. You want them to be at the origin of the coordinate system. And what we're trying to find usually is this diagonal. So you need the diagonal of the rectangle. You use the Pythagorean theorem to get the diagonal. So let me go through that with you. So let's see, we have 10.11 meters to the right, or in the positive x direction, 42.40 meters in the positive y direction. So now we need the Pythagorean theorem. So that means you need 10.11 squared plus 42.4 meters squared. I'm going to add those together. And now I need the square root of that. And I get 43.6. So that's the magnitude, 43.6 meters. Now, how do we get that 76.6 degrees? Well, that's inverse tangent of the y over the x. So, the absolute value of that. So we have inverse tangent. I always forget and put in extra parentheses, of 10, no, try it again, 42.4, that's the y, divided by 10.11. And we get 76.588. Which you can see is 43.6 meters, comma, 76.6 degrees. Now, I want to emphasize this was in the first quadrant, so I didn't have to worry about the signs, the SIGNs of the components when I was finding the angle. But you want to be sure that you always find the reference angle, which means you're just using the absolute values of the components initially, and then you convert it into the standard position angle based on the quadrant. That's almost the end. I just want to talk to you about the notation a little bit. Your author uses this little X with the caret above it and Y with the caret above it. Physicists usually call that caret a hat, so that's X hat, Y hat. And so in addition to writing it in ordered pair notation, you know, comma or parentheses, a sub x, comma, a sub y, then close parentheses. You can also say a sub x in the x direction, that's x hat, plus a sub y in the y direction, y hat. Or some authors use I hat, j hat. So it's just another notation for vectors. Okay, that's all I have on vectors, and I will see you in class on Wednesday. Stay warm.